We have previously defined what a unit vector is, and that's a vector that helps us define the direction of something. And we say that it's a unit vector because it has a magnitude of 1, and we also say that it has no units, right? The units basically come from whatever magnitude you're multiplying to that unit vector. Now, it's important to define unit vectors if we know 2 points along the line of action of those unit vectors. And that's what we're going to see in these videos. We're going to see the concept of defining a unit vector when we have 2 points defining that line of action. So let's call this unit vectors. And this is in particular on the line of action, right? Divided by 2 points. Divided by 2 points. Okay. Alright, so what I mean by that is, let's say that we have our x and y axis. This is y. This is x. Let's say that we have 2 points, and by the way, this extends to the negative as well. So let's say that my point A is somewhere in here. My point B is somewhere in here. And I'm interested in defining a unit vector in that line of action from A to B. And the direction is also important. So from A to B, that's our interest. Unit vector in that direction. So it will be a unit vector that way. A unit vector AB. Remember that hat indicates that it's a unit vector, and the AB is from A to B. Now, where do I draw that unit vector really is not important, because you can slide the vector along the line of action. It wouldn't make any difference, right? All right, so how do I do that? Well, we know how to calculate the position vector RA and the position vector RB, right? So the first thing we need to do is to calculate the position vectors RA and RB. Now, why are we doing that? Because the next step is to calculate a position vector RAB. This is from A to B, and remember that direction is extremely important. RAB is a different vector than RBA, right? Now that we have the position vector AB, the next step is to calculate the magnitude of RAB. And once we have that magnitude, what we need to do is to finally calculate our unit vector AB as my RAB over the magnitude of that vector. Since we're dividing by the magnitude of the same vector, what's going to happen is that the magnitude of that unit vector AB will become 1. And if you look at the units are going to be the same at the top and at the bottom. So that unit vector will be unitless. So those are the steps that we need to follow. The first, the calculated position vectors RA and RB. And in some cases, you might be able to skip that step if it's clear how to calculate or how do you find the vector RAB. So that's the position vector from A to B. Then you can calculate the magnitude of RAB. And then finally, you can just take that vector RAB and divide it by that magnitude RAB. That means taking each of the components of that vector and divide it by that magnitude.